the YouTube is live. Meeting is on live. Kindly check it out. Okay.
Yeah, it's like. Yeah, it's on live. Okay.
I'm starting to allow participants. Okay, they are in the waiting room. I'm starting to allow. Okay.
Yeah, okay.
I think Raghavendra, you can admit the participants, right?
Yeah, I have started, ma'am. I have started admitting them, ma'am.
Raghavendra, is YouTube recording started up?
Ma'am. Yes, ma'am. It has been started.
Oh.
It's now.
And I'm sharing the YouTube link in the group also, ma'am, so that you can able to see.
Good afternoon, Shivakumar.
Good afternoon, sir. Sir. Hello, can you hear me, sir?
I can hear you. Rajaraman here.
Good afternoon, Raja.
Good afternoon.
Good afternoon, Dr. Preeta.
Good afternoon, sir.
Very good. I think you have to check his presentation, whether it is you are able to.
So we have checked it, sir.
Okay, fine. Is Mr. Nanda there?
Sir, you'll join in 5 minutes, sir.
Fantastic. Very good.
Raghavendra, you just try with the video also once.
Yes, ma'am. Sure, ma'am.
He has got any video to run?
No, sir.
Okay, only presentation. Okay.
Yes, sir.
Inside the presentation, there are few videos.
Is it a GIF file or it's separate video file?
No, it's embedded in the
Okay.
presentation.
Okay.
Society President, and I'm pleased to welcome you to today's webinar and training. You have a very interesting
Okay.
Video is working fine, ma'am.
Yes, sir.
Some lapse is there. Just check while running.
Yes, sir. There will be some small lag will be there, sir. Due to network connectivity, there will be a small lag, sir.
Now, how many are connected as of now?
35.
36, sir.
How many you are expecting totally?
500 above, sir.
Okay, if it is more than 500, we can't do it. No, in Zoom.
No, sir. We can't do it in Zoom, but we are having a YouTube link is available, sir, so that they can
Okay.
able to see that.
But they are aware. Well, because if they try, automatically it will change over to YouTube. What does it do?
Sir, yesterday
Sir,
we have sent mail to all participants, sir.
Okay.
So link, everything is shared to them. If they come late, we have informed, like you have to see the live streaming only.
Okay. What you do, somebody keep watching the emails. If somebody says they don't know, they are not noticed properly,
Yes,
or
sir.
mobile, even you can allow them to enter later, because when he is talking, somebody can keep watching that.
Yes.
Yes, sir.
Yes.
So next time we should charge for this.
Yes,
Okay,
sir.
Brita? Yeah.
Yes,
This
sir.
is a good thing. Dr. Monica Agarwal has agreed. You coordinate with her, except the
Yes,
date, and you can announce
Yes.
today also. There'll
Sure,
be,
sir.
or maybe Mr. Nanda Kumar can announce, because he's talking about the opportunities and
Yes, sir.
why we have to do. So will you be talking about this competition, FTech, and two more what you have announced?
Sir, why in your introduction speech you'll be telling about the
I can
competition?
tell.
no?
Okay,
Yes, sir.
I can tell about the competition. Then what about these two announcements, which is internship as well as
Nanda Kumar,
promoting
sir.
the,
Nanda Kumar, sir,
Yes.
presentation.
it is there. Okay, fine.
Yes.
Both of them are there. How many of them are registered now, enrolled for the student membership? You don't know.
No,
No,
sir.
sir.
Okay.
That is not known, sir. Yet.
Okay. Maybe you, while speaking, you tell them whoever had done, they can put in chat box.
Yes, sir.
Okay, that you can record. Tell them in the chat box whoever had already enrolled, and they can enroll them. So these are all some announcements which HEMA can make it.
Yes, sir.
So first it will be.
Am I audible?
Sir, first it will be your welcome address.
Okay.
After that, President MTS video, sir.
Okay.
And you
Then
take the-
secretaries.
Am I audible, sir?
Yeah, you are audible.
Thank you, sir.
But voice is not clear.
My voice, sir?
Some echo is coming.
Can you hear me, sir? Hello?
Yeah. So this recording will be there?
Yes, sir. Zoom will record.
Okay, because we need to share that with the MTS. They will uplink in their website.
Yes, sir. Recording is going on, sir. No issues.
Oh, you don't start now when the actual program you start.
Yes, sir.
So I request everyone to mute.
It's automatically muted, sir.
Okay. Once he starts, mine also will be muted, or I have to mute.
You can unmute yourself, sir. No issues.
Oh, okay, fine. You will automatically mute everyone. That is, you have
Yes,
a
sir.
control over it. Yeah,
Yes, sir. Yes, sir.
that is fine. Because at times some people register in two places. That echo is really irritating. So, better you take control over it.
Good afternoon, sir. Monica here.
Good afternoon. How are you?
Sir, I'm good. How are
Very
you?
good. Yeah, fine. Had your lunch?
Yeah, sir, I'll have it later. The late
Oh, okay.
breakfast.
Okay. So we got a message from MTS president that will be shown here now. That's a good thing. They have immediately responded.
Okay, great. Sir, I didn't get my money. They are saying that the bank over there in US had some issues. So that's why I did not got.
Okay.
I mean, the wire transfer has not confirmed.
Okay.
I was trying at my bank here and finally
Okay.
I found out that it has not been credited.
Okay. Even in IIT, it took about 20-25 days to get. That is during that lockdown period, real lockdown period in March. Somehow this money doesn't come so easily. It takes time.
Yeah.
In
For
fact,
me
we
also,
could
it's
track.
almost.
Yeah, we could track Amit. They have paid in February itself. So that they have to check. They are given the bank detail in February. They have transferred this money. For them
Okay,
also
that's
difficult. Their accounts department is not in the office. They are at home.
The sir has joined the meeting.
Yes. Good afternoon.
Good afternoon, sir.
How are you?
All good, all good. Vinayak Chaturthi Puja over, so
Very good. So we are starting on a good day. We never notice. We are starting with Raja and the good response.
Good afternoon, Nanda Kumar.
Good afternoon, sir.
How are you?
All good, all good.
Good, thank you.
Yes, sir. Good afternoon. I'm Preeta.
Good afternoon, ma. Good afternoon. Good afternoon. Good afternoon. So we're waiting for participants now, or?
Yes, there are at present 62. One by one, they are clicking.
Yeah. Okay. It's not easy to coordinate so many people.
Yes, it's 2 o'clock. How long will wait?
Sir, another 10 more minutes. 10 more minutes, sir.
Okay. Because so many webinars floating around.
Yes, sir. But today's webinar count is less, sir.
Okay.
Because of Ganesh Puja.
Yes, sir.
They may join late, maybe. Whatever we are speaking, is it audible to everyone, Raghavendra?
Yes.
Yes, sir. It is audible, sir.
To everyone, all
Yes,
the
sir.
participants?
Yes, sir. Everyone it will be audible.
Okay.
Devraj sir, good afternoon, sir.
Hello, Devraj sir. Good afternoon, sir.
Can we start now?
I think.
Yes, sir. Yes, ma'am. We have reached almost 104 participants.
That's what I'm telling. I was looking for the magic figure. We can start.
Okay, sir.
Shall we start, sir?
Yeah. Is it Dr. Devraj there? Good afternoon.
Sir, good afternoon, sir.
Welcome. Thank you for joining.
Thank you, sir.
This is a maiden attempt for us. Thank you. You start, Hema.
A very good afternoon to everyone who have taken their time to attend this online webinar conducted by MTS India section. Let me introduce myself. Myself, Hema Jayakumar. I'm handling the event coordination part of MTS student section. As a quote goes like this: knowledge is power, but when it is shared, its power gets multiplied. MTS aims to live and stand by this quote with its world-class mentors who are always student and manage being connecting bridge between the society and young minds. Firstly, I would like to introduce Dr. Venkateshan, Chairman, MTS, the guiding light behind this section, who has been the greatest motivation to the present generation people through his valuable ideas and enlightenment. Dr. R. Venkateshan has 37 years of experience in the field of ocean science and technology and has earned his PhD degree from Indian Institute of Science and is US Fulbright Scholar with honorific position at the University of Manchester, Vermont, USA. He passed PG Diploma in Maritime Law at the Tamil Nadu Dr. Ambedkar Law University in 2019. He has his credit in Maritime Law in 130 papers in 64 journals, 3 books, 7 product technological transfers, 2 patents awarded, and 5 applied. He holds many positions in technical societies, including executive member IEEE Madras section, senior member IEEE, coordinates IEEE student project funding, NIOT student autonomous underwater vehicle competitions, and travel to 38 countries. He is honored with 24 awards, including UN Outstanding Service Certificate, MTS Lockheed Martin Award, Fellow of MTS, and Fellow of NACE Award. He is also teaching at the IIT Madras, IIT Karanpur, and IIT Bhubaneswar on ocean policy and ocean measurements and instrumentation. I would like to start your session with the welcome address, sir.
Thank you, Hema. Thanks to all of you. It's dear participants, particularly students and the experts who are present here, and Secretary Mr. Nanda Kumar, and the learned resource person Mr. Rajaraman, whom I know him very well, and he is our person to start this our maiden initiative to have webinar cum training program. This is Dr. Preeta's brainchild to have such an activity for the students by MTS India section. And the topic today will be on ocean survey and sampling. He's our person. I don't think anybody has such a vast experience to share with their expertise from the field as well as the industry perspective. He will be able to explain to the student. The main focus here is to share the knowledge what you have got, particularly to the students, and look for newer avenues and opportunity. Globally, blue economy is considered as one of the new thrust area. There are more opportunities for all of you as students from different disciplines in engineering to come forward and contribute. So I'm sure that this particular initiative by MTS India section would be very beneficial to you. And I'm also glad that we have been appreciated by the Marine Technology Society headquarters in US. And Mr. Nanda Kumar will explain about MTS. I would like to say that our MTS president, Ms. Edgar Velpelis, she has given a short message to all of us in a very short notice that will really motivate all of you. We also urge you to join us as a part of student member. We have been having very good activities. About 9 student sections are there. And there are umpteen number of opportunities for you to interact with globally with different resource person in different disciplines. And different committees we can be member. That is the main focus here. There will be few announcements today on for the MTS student section alone. That will really make you to become a member and interact with all of us. Thank you one and all. And with this, I request Ms. Hema to proceed with the our activity as per the agenda. Thank you very much.
Now we'd like to present the short video by MTS President.
Good afternoon. I'm Stanka Willis, the Marine Technology.
You can see the video now. Is the video audible?
We can see
Society President, and I'm pleased to welcome you to today's webinar and training. You have a very interesting lineup of speakers. I would just like to take a couple of minutes and talk about my philosophy on MTS and why I think having students participating in MTS is so important. MTS's vision is to be the leading authority and advocate for marine technology and resources while promoting member success and public understanding. And both the member success and public understanding are two important points. So when I think about MTS, I think about it in three ways. We connect, we catalyze, and we communicate. So what do I mean by that on connection? Our committees advance technologies by bringing industry, academia, and government to discuss standards and protocols, lowering the barriers and opening the opportunities for the use of technology. Our sections are often cross-discipline areas of practice where professionals can get together and talk to each other. And you, the students, in our student sections, this is where you come in. You are our future leaders. We hope to give you the opportunity to connect with those that are already in the field. Learn through our events, such as these, publish and present at our MTS IEEE OES Oceans Conference, as well as MTS Underwater Intervention. These conferences and webinars keep us linked together even when we are physically apart. When I look at catalyzing or catalyzation, from the recognition of the ocean enterprise to the tech surges to the CMAR Tech certification piloted with the SUT underwater technology, MTS is a catalyst for change on the leading edge, which is bringing together skilled professionals to share best practices. We're also committed to diversity, inclusion, and equity, and we're working to undertake actions to remove any barriers that prevent all members from reaching their potential and contributing fully to MTS. So it is through you, our students, who are going to bring us greater awareness and understanding on how to be a diverse and inclusive society. On communications, MTS works to bring the diversity of voices within the marine technology to speak together and communicate key messages for decision makers, for policymakers, for the public, for scientists, and we need to make them clearly accessible and in dynamic ways so that we ensure science and technologies propel us to achieve a sustainable blue economy. So again, I'm looking to you, the students, who know how to communicate in different channels than I might know how to communicate, and in new ways that make it exciting across the world what our message is and how important the science and technology is in our daily lives. And on that note, I encourage you to participate in the MTS India Student Technical Story Writing Competition, Fishing Technology, Energy and Communication, which will end on 31 August. So as you go through this seminar and this training and think about how you can work as a student with MTS, let me finish with this final thought. It has always been important, but even more important now, that we come together, my generation, your generation, to solve the problems and the opportunities we have before us for a sustainable planet. Thank you.
We thank our president from MTS HQ for sending us the short video in a short time. Now I would like to introduce our MTS India Section Secretary, Mr. Nanda Kumar, who is also the CEO of Electronic Lab Chennai. He has always been the mastermind of friendly approach towards grooming the young generation on becoming the best citizens of the country. Nanda Kumar started his career in offshore drilling in 1981 as a communication and air traffic controller. Then worked in merchant ships as a radio officer and diversified from the communication side to the navigation side and rose up to the rank of a chief officer. After a 10-year stint in the offshore and merchant marine industry, he then started his entrepreneurial debut and set up India's first GMDSS training institute in Chennai. During the same period, he started Electronic Lab, which initially started as a marine communication and navigation equipment sales and service company. His company has further diversified into aviation connectivity and tracking and offers the office in the sky concept to over 130 aircrafts. This expansive knowledge has created a unique image for him in the industry and among students. Thank you, sir, for always being in support to MTS India. I would request sir to start his presentation on the benefits of MTS to student community.
Thanks, Emma. I think you need to allow me to share the screen.
Yes, sir.
Yes, sir. Now you can able to share your screen, sir.
Yeah, I can. So the screen is visible?
Yes, sir.
Okay, thank you. Good afternoon, everybody, and happy Ganesh Chaturthi today. It's nice to see over 110 people logged in as of now. I want to just go through a little bit on the advantages of being a member of the MTS Association of Membership. Like our president rightfully said, connect, catalyze, and communicate. That is exactly what we do. We connect people, we connect students with their research programs, we connect students who want to have mentors in the various expertise of maritime technology. We catalyze ideas, and then we can also communicate by way of various forums such as TechSurge and other camps that we conduct. About MTS. MTS was originally founded in the United States around 1963. We have overall 40 student sections around the world so far. And our guiding purpose is to promote awareness, understanding, advancement, and application of marine technology. The International Society also brings together businesses, institutions, professionals, academics, and students who have some connection with ocean engineering or technology. Like you would see here, we have myself, we have Dr. Venkat, and we have a lot of other people. The section in India was founded in 2015 as probably the youngest international section of the MTS US. And our mission was to facilitate a broad
Sir, Nanda Kumar, sir.
You have unmuted.
Yes.
Okay, I unmuted. But we need to get these notification alarms shut. I think that is what is irritating everybody. We basically facilitate a broader understanding of the relevance of marine technology to wider global issues, enhancing and decimation of marine technology information. The society or the Marine Technology Society also promote and improve marine education in the related fields, and also help in advanced development of tools, procedures that are required to explore, study, and further the responsible and sustainable use of the oceans. Our mission is to be a leading authority and advocate for maritime technology and resources while promoting member success and public understanding. Today, MTS India is a growing organization boasting members from prestigious institutions, colleges, from business houses, and other ocean engineering technologists, policymakers, and educators. As a section, we have a governing body as per the Government of India regulations of the Societies Act. We have Dr. Venkateshan as the chairman, and you can see myself, the secretary, and rest of the leadership. Just a word about Dr. Venkat, who has been the pillar of the organization, and we can call it as the focus light of MTS India. He is from NIOT, National Institute of Ocean Technology, Scientist G, with quite a lot of awards. He's been crowned with several awards for his exceptional contribution to the maritime sector. You know, we can write a big book on that, but I'm going to stick to only the awards that he's received in the last few years. So the most prestigious award was the Lockheed Martin Award that he was given by MTS headquarters for Ocean Science and Engineering Award. He is the first Indian to be honored by this organization that has been established in 1963. He was also honored with the NACE Fellow Award in July 20 recently by NACE International USA. And he was nominated and appointed as the vice chairman of the newly restructured World Meteorological Organization again in June. And the MTS headquarters honored him with the prestigious MTS Fellow Award in November 2019. As regards the chapters in India, we have certain conditions that needs to be fulfilled. So we are not rushing. We have quite a lot of applications from colleges across India for affiliation and membership. So right now you can see the 9 colleges that have been affiliated or have a student membership or student chapters of MTS in their respective colleges. The list is there on the screen. And it's remarkable that in a short span of about 4 years, we have conducted something like 107 events. Quite a lot of them have been with huge international participations. We have different segments for various competence. We call it tech surges. Basically, take a hot topic of the day and discuss about it. We also conduct competitions. We have quite a lot of technical talks and outreach programs that are conducted by the student sections of our member colleges, and quite a lot of industrial visits as well, student camps. These are some of the photographs you would see. You can see that we have the top people from Coast Guard, from the police department, all have participated in our programs as a chief guest or as a mentor talk program. This was a photograph from the Texas 2016. I think that was the first ever event we conducted. And we had the SRM inaugurations. These are the various other competitions and field visits we have conducted for students. On the right, you would see the port visit for school students. This is a bit inauguration and the school awareness program that they conducted on plastic awareness as well. This is again competition conducted by the BIT College for students. On the extreme bottom right is a competition conducted by AMAT. So as you would see that we have been very, very active. This is the IIT Delhi MTS inauguration. We have been very, very active with quite a lot of events happening and quite a lot of technological seminars and workshops and training that students in colleges, the young students, undergrad students can hugely benefit from the wide variety and diversity of knowledge we have in the group. This is the proudest moment for us when Dr. Venkat and me received the MTS India section was awarded the best section of 2017. So that was a great achievement just 2 years after the inception. So we received this award in Alaska. That was a great achievement for us. And this was the student section, SRM student section, winning the Outstanding Student Section Award. Again, luckily, 2 of the students were studying in a nearby university, so they went to collect the award in the function held in the US. I can't remember the state. So what are the benefits of the MTS members? What is the benefits of being a member? We do offer international scholarships. I will come up with a list of people who have got scholarship money from MTS India. You get a good exposure and participation in real life technical programs. We do have a lot of arrangements and opportunities that we can get for people who are members for internship. The student chapter also gives you a possibility to take up administrative positions, to show leadership qualities. If you come up with papers, we can have it published in the MTS journals. They're all international journals. You will get an international membership certification, and you will get a letter of recommendation for higher studies in case you are appearing for certain colleges. A letter from MTS does play an important role. There is an MTS Career Center for Job Opportunities through which you can also seek jobs. And if you are doing any technical research on certain domains within the maritime sector, we can help you. These are some of the people. As you can see, that almost 17 lakhs has been distributed so far as scholarship. As you can see that colleges from SRM, NIT Trichy, and even, it's mostly SRM and NIT Trichy who have taken advantage of this scholarship program. And these are the proud students who have received quite a lot of money. It's quite a decent amount of money that has been given out at scholarship. So this is another opportunity for, if you're a member, only members can enter into competitions or submit papers. And once it is selected and approved, then the scholarship is awarded from MTS US. As part of this seminar, so we thought we will announce something special, is that yes, all MTS member students will get priority for internship opportunities in member companies. We will be conducting periodic contests on a yearly basis with prize money and funds. To enjoy this, all you have to do is to enroll your name in the exclusive MTS membership website. It is www.mtssociety.org under the student category membership program. And thank you. That's it from my side.
Thank you, sir. It was a great presentation. As always, you were a delight to hear. Now I would request Dr. Venkateshan sir to invite Devraj sir to give a small talk.
Yeah, it is for the students to note that we have a dean of the prestigious college, Kalasalingam College, Dr. Devraj is here, who has been mentoring students, and I thought having him here with us, maybe a minute he can spare the importance of having students getting involved in such a society, how it will benefit in their career. Thank you.
Good afternoon, students, and thank you, Dr. Venkateshan sir, for inviting me to share a few words with the students. Also, I would like to thank all the organizers for inviting me to this occasion. Yeah, from the presentation given by Dr. Nanda Kumar, I found that very impressive benefits he has shared, and also he discussed the various activities which were conducted by MTS Society in the recent period. Even in fact, I have also participated in one of the events organized by MTS Society in association with the SRM University recently. It was an event organized for the students. In general, MTS Society is very dynamic for the past few years in organizing various technical events for the benefit of the students. In addition to that, I was very much impressed with the scholarship and the internship provided to the students for their benefit. Not many professional societies are giving this much amount of generous funding for the benefit of the students. In fact, myself and Dr. Venkatesan sir, we are associated with the IEEE for the past few years. There are also a number of benefits are there, but still I could found from the presentation made by Dr. Nanda Kumar, the support offered to the student community is very much impressive. Yeah, I found 100 plus students from various engineering colleges. They are participating in this webinar technical event. Students, as part of your academic activity, would be learning a lot of things from your regular teaching learning process. Apart from that, it is always better to associate with technical societies like IEEE, ISTE, MTS, etc. Say want to have a networking with the people who are working in your domain. And apart from that, when you go out for your project work or internship, when you are associated with such professional societies, always it will make your job easier. Maybe when you look at the name of the society, Marine Technology Society, you need not think like it is relevant only for students from ocean engineering or marine technology alone. See, even though it is related, more relevant to the people who are working or studying marine technology or ocean engineering, but the technology behind the activities which are done by and the activities which are supported by the MTS Society is very generic in nature. Even students from computer science, in fact, they are doing a lot of technical activities related to communication, data analytics, and those things they are working, and their support is also related to those domains. So people from other domains like communication engineering, computer science, and also even in fact electrical engineering, they can also associate with the society for extracting maximum benefit. So I sincerely request all the students who have joined for this webinar through online to think of having a close association with such professional societies for your professional career. With this, I would like to close my brief speech. I would like to once again thank Dr. Venkatesan sir for inviting me to interact with you. Thank you all, and my best wishes to each and every one of you who have joined in this webinar. Thank you.
Thank you, sir. Thank you for your motivational speech.
Thank you, sir. Now I would request Dr. Preeta, who is the student coordinator of MTS Student India sections, to introduce our resource person for the hour.
Yes, good afternoon, one and all present here. I am much privileged to introduce our resource person, Mr. V.S. Rajaraman, Vice President, Norenco Private Limited since 2015. He is heading the Oceanography Division in Chennai branch. He is handling scientific operations in all ocean research vessels belonging to the Government of India, such as ORV Sagar Kanya, FRV Sagar Sampada, ORV Sagar Midhi, ORV Samudra Ratnakar, RV Sagar Manjusha, and so on. He is handling the buoy-based ocean observation for National Institute of Ocean Technology on contract. He started his career in National Institute of Oceanography, Goa in 1982 as a mechanical engineer. He had been a part of the scientific team in the survey of polymetallic nodules in the Indian Ocean, an Indo-German collaboration for upwelling studies in the Arabian Sea and Bay of Bengal, and many other oceanographic studies. He has sailed for years in various international and Indian research vessels for survey and scientific operations as a team leader and mooring master. Recognized contributor to the coastal and ocean science programs such as Deep Sea Mining Project, Ocean Thermal Energy Conversion Project, and Ocean Observation Systems. His contribution includes indigenous design and development of oceanographic sampling equipment for coastal and deep sea research, and that is continued till date. He has published around 10 papers including a concept for deep sea mining during career at NAO Goa. He has traveled around the world for training, conferences, and ship dry dock management. On behalf of MTS India section, now I request our resource person, Mr. V.S. Rajaraman, to continue with the session.
Good afternoon, everybody. Am I visible? Yeah. Thank you for the opportunity. I'm Rajaraman from Norinco Private Limited, handling the oceanography group in the company. The time allotted to me is very little for covering the ocean survey and sampling, which is a very vast subject. So I will directly delve into the business talk that we have right now. I'll start the presentation immediately. Is it seen online? Yeah. Are you able to see the presentation online?
Yes, sir.
We are able to see. Only make it full screen and start talking. We are able
Yeah,
to
that's
see.
what.
You can continue the talk. No problem.
Yeah, just a second, and let me get it in full screen.
Effect.
Yeah. Ocean survey and sampling. Oceans cover 2/3 of the earth, and this is something everybody knows, and it supports all form of life on earth. There is nothing that is not touched by the oceans one way or other, whether it is human being or any other life form. We have some way, we have our connections with the oceans. Oceans keep a record of all the events that has happened yesterday, day before yesterday, millions of years ago. Everything is, there is a record, is a locker for all the events in the ocean. So our interest is to see how we can use this, explore this records and then connect with the present day activities and then forecast in the future things that are going to happen in the future on the earth, which will benefit all the human beings on the earth. And survey again is a tool that provides all the facts on the available activities on the screen on the ocean, and we will be continuing with the. I'll move to the next line, that is the survey and sampling of the oceans. When it comes to survey, it gives you an understanding of various objects available in the object of interest available on a geological distribution. Where is a mineral distribution? Where is biological distribution of fishes or anything? And there are several other atmospheric and things connected to the oceans. We map everything on a geological distribution and say that, okay, this is where we can get this thing. This is how they are changing over the time, or some of the things, or the distribution from one region to another region, how they are changing. These are the studies that we would like to study. That is why we carry out surveys. And sampling is one of the major components that go into the, one second. We need sampling to do all the supporting requirements for the survey. So we have several instruments and equipment that helps us to pick up samples from the ocean and connect it to the survey so that we understand better the distribution of all these important objects in the ocean. When it comes to survey, there are various surveys. It is a very vast area. When we call it survey, it is a very generic name, but there are several surveys that one can carry out to understand the ocean and ocean physics. Bathymetric survey is one of them, which is actually finding the depth at the place where you are standing, water depth, and then putting it on a map to see, to create a map of the ocean's seafloor. So bathymetric survey can be conducted by different methods. When you start, when you are close to the shore, you can just drop a stone line and then measure the length of the line and understand what is the depth at that place. But ocean is the maximum depth at the ocean somewhere is around 11,000 meters, that is more than 11 kilometers, where it is not possible to use such means. So one requires other means of finding out the depth of the ocean at that point. What we do is use something called echo sounder, which is actually, it works on the principle of transmission of sound. You create a small pulse, sound pulse, wherever you are on the sea surface, and this sound pulse travels all the way down to the sea floor and then reflects back. The time it takes for this travel is measured, and we divide that by 2 and multiply that by the speed of sound, which is on an average 1,500 meters per second. And we use this information to pick up the depth at that point. Similarly, I mean, what you see on the left side of the slide is the record of the echo sounder. That is, all the information gets stored on the in the ship, and then you create a map showing the depths at every location that the ship has traveled, and then connect them with the same depth locations on the map with respect to the latitude or longitude. So you know what is the depth in that region where you have taken up a bathymetric survey. What I'm showing here is another form of what you've seen in the previous slide is the single point echo sounder, where you just get depth of the ocean at that particular point where your ship is standing. However, today the technology has advanced quite a bit. You are able to measure the depth wherever you are. If you are standing, your ship is at a depth of 6,000 meters, you are able to exactly map the 12 to 18,000 meters below the ship level, so that you create a map very fast. What you see here is the map created by such a mechanism, such an equipment, which is called a multi-beam echo sounder. It throws an array of sound pulse into the sea, and then the reflection of this sound is recorded onto the hull of the vessel where the transceiver is there. And this sound pulse is converted into the mapping section, where you can see a record of the ocean floor. What you see on the right side in the map, the red area is the highest region, and the blue area is the lowest region, the deepest point in that location. So even though you are standing at the center of the map, you are able to get everything in one single pulse, one single stroke of the array of pulses that you send. This is the multi-beam echo sounder. Today we are using this equipment in all our vessels. We have been able to map a lot of regions around the Arabian Sea and Bay of Bengal, which is on both sides of our country, and also in Indian Ocean, where we have a lot of interest for the country. So we were able to map most of these regions in the last several years. Next, we move on to the geophysical survey. Is this obstructing the view, or are you able to see the title of the slide? Hope somebody can respond. What we see here, what we see here is geophysical survey, the next form of survey. It is actually to understand what is below the seabed, the structures below the seabed where you are standing, the vessel is standing. What we do is create a massive sound pulse using a tool called air guns, and then this sound pulse can travel below the seabed, much far below the seabed, and the reflections are recorded on a stream, a long stream of hydrophones. These are converted into electronic signals and then mapped on the record, where you can actually get to know what is beneath the seabed. This is useful for mineral explorations, oil and gas explorations, and general understanding of the crust of the sea floor on the earth. It is a major exercise. There are smaller versions of this seismic. It is called Seismic System. The smaller versions are available for understanding very top layer of this thing using a very small sound pulses, whereas the major versions will have a long 7 to 10 kilometers long hydrophone streamer array and a very large sound source using air guns. These guns blast in the sea floor on this sea surface, and the sound pulse is traveling down, and the reflections are collected with the same technology as the time taken for the sound pulse to travel back to the streamer, and this is recorded on the system, and you get to know, understand the seafloor characteristics of the wherever you are traveling with the ship. Here is a record of what the type of record that you get when you run a seismic system, geophysical seismic observation, like I have shown you in the previous slide. You will be able to map the rock structures and sediment structures, clay structures, and then up to probably around 10 kilometers below the seabed surface into the ocean. We next move on to magnetic survey. All of you know that the Earth has got its own magnetic field, and it varies from location to location based on the mass of the massive structures on the seafloor. A magnetic survey provides some information about this, and we use the magnetometer to understand the structure magnetic intensity variations of the sea wherever we have been traveling. For it is also in connection with the geophysical survey to better understand the seafloor characteristics and the huge masses around the sea mounts and such things, and mineral resources around the seafloor. We also have additionally gravity surveys, which measures the gravitational pull around the masses in the Earth's crust. And these are surveys that are connected to the geophysical parameters of the Earth. And these are regularly conducted by the geophysicists and geologists who are interested in understanding the oceanographic parameters and the Earth's geophysical parameters in the ocean. Next, we move on to Fisheries Survey. This is again to understand what type of fishes are available in the ocean and when it is available, what is their distribution. Basically, this is the information is useful for our life cycle, food cycle, and different time of the year, different regions in the year, in the Earth. We have on the ocean, we have different type of fishes available, which are kind of one fish is a food for another type of larger fish, and the cycle goes on, and we try to understand what is available as a food resource for the mankind and other living fishes in the ocean. So we go on to other form of surveys. We have Physical Oceanography Survey. Physical Oceanography Survey actually covers the temperature variations on the seafloor, in the water column, and you also observe the density variations on the water column. We have various instruments to collect this data, temperature probes, and density, salinity measurement tools to understand the water movements of the sea and take the measurements to predict the atmospheric impact on the ocean waters and the current ocean currents. Then you have chemical oceanography survey, which measures the various chemical parameters of the ocean water, which will lead to the measurement of pollutions and you get understand what is the effect of all the fresh water that is going into the sea, and also the air sea interaction that is happening on the sea surface, their impact on the seawater, and subsequently how they affect all other living forms in the seawater. This is the chemical oceanography survey. And we also have the biological oceanography survey, where we try to collect all the tiny species that are living in the ocean, which becomes the food for the next larger species, and again they become the food for the larger species. Ultimately, when it comes to the big fishes, we eat those fishes and they are our food. So this continuous cycle is this is the starting points for this cycle, and we try to understand this by this biological oceanography studies. We also have atmospheric surveys, wherein we try to understand the variation of atmospheric parameters like climate changes using various tools. We try to measure in time series the variations of the seawater temperature below the sea level, and the air temperature above the sea level, and the solar radiations and wind speed and wind direction below the water column. We also measure the current and temperature and salinity variations on the sea floor in the sea, to understand the movement of water from one region to another. When the movement of water takes place, it also affects the climate and how they affect the total atmosphere in the ocean and their effect on the land where we all live. So these are various surveys that are being carried out in the ocean, and all these surveys have a lot of subdivisions in their activity, and every small event, a small portion of this survey connects with another one and another one, and they all provide tools for us to understand what has happened several years ago, several millions of years ago before, and how it connects with our today's living, and what is we will be able to use this data to forecast what happens in the future, whether any connection is there to what has happened in the past to the future. These are all things that we will be able to study. And what you see on the screen now is, on your left, is the Data Buoy ocean observation system, which is deployed around the oceans, which carries a number of sensors for wind speed, wind direction, solar radiation, and below this floating device are long moorings which carry several sensors for measuring the seawater temperature at different depths. And you also have the measurement of salinity, which is actually the amount of salt content in the seawater. These are measurements taken at regular intervals throughout the year. For several years, we have been doing these surveys to understand and forecast what happens, what is going to happen atmospherically for the rains and wind and farming and everything. These are tools to connect us with the science that is happening there. On your right is the similar buoys which are deployed in different locations by Government of India through National Institute of Ocean Technology. And these are continuously sending their measurements to the institution at Chennai, where you can see at the bottom left, people sitting there and monitoring this data that are coming continuously 24/7 for many, many years. and for trying to derive information from these numbers, and then try to give forecast to farmers and fishermen and all the coastal, anyone who's affected by the one way or another affected by these data. On your right, you see the data stream that is coming out continuously, and these are disseminated and distributed to various research institutions in the country for further processing and forecasting. Again, coming to the atmospheric survey, what you see here is the same data buy which is there, and connected to that is below an ADCP acoustic Doppler current profiler, which collects the data on the movement of the seawater in the water column. And the same in a graphical form is explained in the middle slide. Actually, there are several conductivity and temperature measurements that are being taken throughout the entire water depth throughout the year. It's on time series, and this information is being processed and distributed. On your right side of the slide, you see various forms of such surveys. The advancement of science that has gone into collecting this data, you are able to have a different type of floaters, which we can throw it into the sea with a transmitter that can connect to the shore station using a satellite. This continuously travel along the current in the ocean, and they collect the same data that is being collected in the data buy, like there's a variation in the salinity and temperature, and several other things like the amount of oxygen available on the sea surface. This information, as they drift in the water, they collect this data and transmit through satellite to the shore station. So sitting in the institution, we are able to acquire all the information from the sea, and then use this information for forecasting and further studies sitting in the lab. This data is disseminated and distributed to all the institutions for further processing. Being survey, as I have told you, is a very vast subject. I have just touched upon very top surface and nano scale surface of the science that is the survey, and because the time available is only so much, so anyone interested will be able to send in a request for understanding more, and we'll be able to respond to you at any time to continue with these studies and for your interest. We move on to the marine sampling techniques now, and there are several types of samplings that we can have. The sampling is basically to provide some input into the survey, and they are the ground truth for the survey. When you try to mark location with what kind of sediments are available, or what kind of water temperature distribution is present in the ocean, or what kind of fishes are, you need to, in addition to the special tools that are available today like sonars and other things, you also have to use certain tools to collect the direct information from the location and then confirm that they correspond to the inference that we have arrived at using the other means. So satellite can predict the ocean using the ocean current. Satellite can give you some predictions on the movement of water, but unless you take actually some samples from that location and compare and check whether they are comparing okay, then it will not be much use. So you need to have the ground truth. And if you have to have the ground truth, you need to have samples from the ocean. So we will cover a little bit on those aspects as well. We start with the seabed sample. Actually, to collect seabed samples from the sediments from the seabed, we need some grabs. On your left, you can see a grab which we send it in open condition using a single rope. And allow it to close at the seabed surface and collect some tough sediment from the seabed surface and pick it up, which will give us some understanding of the surface, whatever sedimentation that has taken place in the very recent times, maybe last month, last year, 10 years back, this information is available on the seabed surface. And this grab is used to collect the sample from that surface for our studies. There's another grab which we send it. I mean, the previous grab I showed you is useful only when you have still water like ponds and lakes where your medium is not moving. Whereas when it comes to the deeper oceans, it will not allow you to operate such grabs because they will rip in the water column itself. You need to have something heavier and capable of going down all the way to thousands of meters below the water level and hit the seabed surface to collect the sample. One of the challenges for collecting these samples is that you cannot have multiple wire ropes going down from the ships to operate this equipment. So this equipment is designed to operate through a single wire rope where it is attached. You can notice on top of this thing there is a single wire rope that is connected, and this rope, this grab is sent down in open condition like this. The moment it touches the seabed, it'll trigger, and then when you try to lift it up, the grab will close, and you collect the top sediment from the grab, and you pick it up to the vessel and then open it and take the samples out. The grabs are useful if you are collecting sediment. Rough estimates can be made by using the sediments that are collected from the top using these grabs, because when you come to the further studies of the seabed, you need to know when for how long this sedimentation has taken place, and you need to understand much better. I'll come to it a little later. These are different graphs that are with the advantages in advanced technologies. We are able to have graphs which will also give you a videograph of the seafloor that we are standing on, and we'll be able to see what is in the seafloor, and then whatever interesting feature is seen in that location, we will drop this grab and then arrange to close it electrically and then collect this grab on top. We know what we have seen on the seafloor using the video, and also you collect the sample, and you'll have some inference of changes disturbances that has taken place when the sediment is collected and from the seafloor and taken to the ship. And as an information, it takes about 1,000 years roughly for the sedimentation of 1 centimeter to accumulate on the seafloor. Each centimeter of the seafloor sediment gives you a history of 1,000 years of what has happened in the past. So each centimeter, if it get disturbed and mixed up, you are losing an history of 1,000 years of your sedimentation process. So it is important that we collect the seafloor samples without any disturbance. So these are some of the equipment which collect the seafloor samples without any disturbance, so that the top it remains on the top, and the next layer and the other layers are intact when you collect the sample without any mixing up, so that we are able to dissect every centimeter from the sample that we collect, and we are able to study these samples to know the history of what has been happening. If this equipment will collect about 50 centimeter top layer of the sediment, which means that we can study the history of 50,000 years using the samples that are being collected using this equipment. This is called the box grab, because the sample is collected in a vertical box that is inserted vertically into the sediment and collected. In the background, you can see that icebergs, which are actually, this operation is happening in Antarctic using one of the research vessels. And what you see in the background is the icebergs which are on the Antarctic Ocean. the previous slide, the sediment sampler is sent in an open condition, and after the penetration of the box into the sediment, the corer is triggered to close, so that when you draw the rope up, the spade will close the bottom, and this is how it is protected. The sediment is protected and brought intact, with every layer intact without any disturbance. This is again in the same region. We have collected the samples. Our team, Indian scientific team, regularly visits the Antarctic region to study the seawater and the atmosphere there, which are having a lot of influence on what is happening in the Arabian Sea in Bay of Bengal. These studies are very important for our surveys on the climatic changes and various other interests. What we see here is a chain back dredge, which we drag on the seafloor and collect solid rock pieces using this grab. We lower it down to the seafloor and then allow the vessel to drift slowly, so that it can break and pick up the rock samples from the seafloor, which are again used for studying the minerals available on the seafloor, on the top surface of the seafloor. What you see here is the free fall grab, which is actually, we have discontinued this grab operation now. The grab top portion, what you see on the orange portion, is it contains two glass floats. These glass floats are buoyancy packages, and just below that you see a grab in open condition with the two heavy weights attached to them, which are disposable. This grab actually does not require any wire rope or any such thing to operate. Deploy them into the ocean, just throw it into the sea, and they travel all the way down to the seafloor, probably 5 to 6 kilometers in the seafloor to the seafloor. As soon as they hit the seafloor, the weights that are attached to this grab, they fall off, and then the flotation is free to come up. When it tries to come up, it closes the grab, and then you collect the sediment, material which are on the seafloor, top of the seafloor. These are collected and brought to the surface, and then we pick up the grab along with the flotation and everything, and pick up the sample from this. These have been extensively used in the Indian Ocean to understand the seafloor in Indian Ocean at a depth of 5,600 to 5,900 meters, where we have certain specific minerals, mineral formations, which are called polymetallic nodules. They are lying on the surface of the seabed. We have extensively used this tool to collect seabed samples from there, and these samples contain various minerals like nickel, cobalt, and copper, manganese, and several other minerals. This mineral mapping we have done using in the survey exercise. We have done the mapping of these minerals in the Indian Ocean. As a consequence of our survey and the sampling exercise, we were able to approach the International Seabed Authority. Government of India has a mining right in the region to tap the resources for the country's operational uses. We again come back to the grab. These are heavy duty grabs, which are again used for deep sea operations, where these are about a ton in weight, and you are able to send them all the way down to the seafloor. And in the Indian Ocean, where we have a lot of interest, which affects our climates and our resources, we need to operate some heavy equipment to travel all the way down. Otherwise, as the ship is continuously moving, these grabs will not travel vertically down if they are lightweight, and we will not be able to collect samples. So we have to make them heavy, and we send it in open condition, and then there is a trigger in the system which drops off when the grab touches the seafloor. and you are able to pick at the, when it is closing, when you draw it out, it closes and then collects the sediment from the top of the surface, and we collect it onto the ship for analysis of the sediment. When it comes to clay and soft sediments, you can use the previous graphs that we have shown you. When it comes to sand sediment, it's a different story, and you will not be able to collect samples in the conventional manner. So you need to have some special graphs with a spring-loaded mechanism. What you see at this location is on both sides we have a special spring which are locked, and once this grab touches the seafloor, these springs are released to hit the grab to collect the sediment and penetrate the top of the sand. Then when we drop it to close, the sediment, the sand sediment is taken into the grab, and then we draw it up. The sediment is picked up, sediment and gravels and rubbles, which are not possible in the regular conventional grab operations. We have to use this type of grabs to collect these things. Whatever graphs we have shown in the previous slides are only for useful for the top surface sediment of maybe maximum 50 centimeter to 1 meter maximum. But we also have an interest in understanding what is below this top 1 meter sediment, and we use something called a corer, and these corers are long tubes which are driven into the seafloor and pulled up with the sediment that is inside the tubing. When we draw it to the lab, we will be able to get at least 30 to 40 meters of sediment in the tube, and we can use this sediment to understand. Like I said, 50,000 years in the tops, 50 centimeters. We can have millions of years of history embedded in the seafloor using the sediments that are collected using the coring equipment like this. This is shallow water in a small near shore. Some of our scientists collecting sediment core in the Antarctic. When it comes to deep sea, we have to go for an equipment like this, where you have a long tube about 6 inches in diameter and 15 to 20 meters in length, and with a heavy weight on top. This corer is sent down vertically into the seabed, and then using its the gravity of the weight that is on the top of the tube, it is driven into the seabed, and then when you pull it up, there is a core catcher at the bottom of this thing which does not allow the sediment to fall off. When you draw it onto the vessel, you will be able to pull out the sediment and then carry out analysis of the sediment, their stratigraphy and informations on top to bottom up to a level of 30 to 40 meters. The longest core available that can be taken using this equipment is about 40 meters in length. There are other forms of such corers. Here is what you call piston corer. The piston corer is, again, there is a piston arrangement inside the tubing. There's a next slide which explains how the piston corer operates. We have a long piston which is kept at the bottom of the tube, and you have a trigger mechanism with a long weight. It is deployed in this fashion. You can see here the triggering mechanism on top, and inside the tubing is a piston, and that is connected in this rope. You are lowering it down to the seafloor, and as soon as the pilot weight, which is attached to the triggering mechanism, touches the seafloor, the corer is released from this triggering mechanism to drop into the seabed. And what you see here is the piston remaining at the surface of the seabed, but the tubing that goes inside the seabed. And the piston remaining in the same position creates a vacuum inside the tubing, so that you are able to collect the sediment much easily, so that without any restriction on the sediment moving into the tubing, so that you are able to collect an undisturbed structure of the seabed in that location. These are very important tools for studying the stratigraphy of the sediment in the seabed. And what you see here is the sediment that has been collected using those piston corers. On top, you see rough sandy type of sediment, and then you have different structures having various thick sediments, and subsequently you have also a clay and very stiff clay at about 40-meter water depth, seabed depth. This is how when you draw the corer out and then cut them to open, this is how the structure shows. This is one of the samples that has been cut, and every section has been prepared like this. It gives you a long history of the formation of the earth and what has been happening many years ago on the earth. Everything that has happened around the earth, in the atmosphere, on the air, on the land, everything is taken to the seabed as records, and these records are we are able to get these records out of the sediments from the sea. It's an interesting science for the geologists to study the sediments and connect them with the future of the earth and how it is going to be. And there's a lot of study that we can carry out using these tools. When it comes to soft sediments like the previous ones, you are able to use the piston coring. Now, when the sediment on top of the layer is sandy or with rubbles and all that, it is not possible to use such tubes to collect sample, because as soon as they hit the hard surface, they'll fall off and it will be a failure. So in such areas, we have to have a different type of coring system. This is a Vibro corer system. What you see here, there is a central tube which can be driven into the seabed using an electrical vibrator which is fitted on top. As soon as this equipment is landed onto the seafloor, the vibrating mechanism starts, and then using the vibration, this central tube is driven into the seabed, and the sediment sample enters the seabed. When you draw it up, actually the bottom is closed and the sediment is picked up intact and brought to the ship. Next, we move on to, from sediments, move on to the water column. We have the various tools to collect the water samples from the sea water column. This is called an skin sampler to collect water samples. This is how these water samplers are attached to the wire rope using a winch in the vessel, and then a series of such water samplers are attached to the wire rope, and then they are triggered after we send them down to the required level of depth that we are interested in. We send a messenger to trigger these water samplers. You see that this water sampler is presently attached to the wire rope in an open condition, and now you will see that how we arrange to close it. So the water at that level is trapped inside the water sampler, and when you draw it, you know that this water has been collected from that level of the water column. Coming to this equipment, the same water samplers are attached to an electronic equipment. This is today's technology. What I have shown you previously is the technology many decades ago. Now today we have very advanced technology to collect the water samples from any depth in the ocean. These are equipments that can be sent up to 5,000 meter water depth. We send them in open condition, and this is called a Ctd system, which is conductivity, depth, temperature and depth system, which is You can collect water samples. You will be also able to collect a temperature profile as you send this equipment down to whatever depth you are sending it. You also are able to measure the conductivity as the equipment goes down the water column. And these are continuously recorded in the ship using the electrical cable that is through which this is being sent. The water samplers can be triggered at different levels from a command from the ship, and each water sample will collect the water from the particular depth at which this equipment is traveling. So, like that, we can have up to 24 to 30 water samples in one operation. So we are able to collect multiple data in one go when you are in the ship. What you see here is this water samplers sent in open condition. As they travel down and triggered at different levels, they are all closed here, and they contain water from different water depths. They, along with wherever we are shutting these water samplers to collect water, we also get the data at that level about the temperature at which this water is collected and the conductivity at that level. So when we draw it to the laboratory, we know when we check the water or the conductivity, we also will be able to match with the recording that we have through the sensors, and we know that, okay, this is the correct information that we collect using the sensors in the ship. And this instrument package also can contain other sensors for nitrites and oxygen and turbidity, and several other sensors can be mounted in the same package, and all the data as the equipment travels in the water column, everything is directly recorded on the onboard computer for future analysis. So when we go on a mission, we do this operation regularly at different intervals and continue this operation at different time of the year, and that is how we carry out survey to predict, to establish as ground truth of the variation in the temperature of the water column and the variation in the conductivity, variation in other parameters, biological and chemical parameters for our interest in the survey operations. Here is a record of the Ctd system that is operated. You get the temperature as you lower the equipment. You also get the sound velocity of the at the location where this equipment is traveling. You also get the conductivity and the variation in the temperature. All are collected in one go. It also collects data from every other sensor that can be plotted for that location. We can get this data continuously on geographical spatials and also on time series spatials. So you can plot all these things on a system, on a geographical map to create a survey of the region for various time in the year, and carry out your scientific understanding of the ocean parameters, changes in the ocean parameters, and how it is affecting the chemistry and biology and everything else in the ocean. We also, for the biological survey, we carry out biological sampling using different type of nets. What these nets do is they have different type of several mesh sizes here at the bottom, where the biological samples are getting collected. The biological samples actually are the food for the higher life in the ocean. So understanding them, they vary with the temperature, they vary with the location, they vary with the year of the date of collection. And so looking at all these parameters, what is available in the ocean, what kind of food is available in the ocean for the fishes there, and how they, what kind of organisms are born at different times of the year, different climates of the year. All these things have their connection to the study of the food cycle, to the study of the atmosphere. So this information is very essential for the oceanographers. So we continuously collect this information when we go on a cruise in the expedition to the sea, traveling from the shore to the deep sea, and then we collect this information from different locations, from different water levels, and compare them, and then create a record of this information for expanding our knowledge. The same net what I have shown you here, today we have an advanced version which is Multi-Plankton Net. So there are an array of such nets with a different, which can be lowered into the seawater, and you can trigger them to close at different water levels. And you also can measure using a flow meter which is fitted to this, and you know how much water has flown through this nets, and what is the amount of material that you have collected, biological samples. And subsequent to this, you also analyze what kind of species that you have collected, and all this information is providing input to the biologists and every other scientific fraternity to understand the activities in the ocean. Today, whatever you have seen are sciences that are happening for years and years, decades and decades. We have advanced equipment today for such studies. What you see here is the remotely operated vehicle, which can contain cameras, which can be operated from the vessel, and directly you can see the visuals wherever this equipment is. It can carry various kind of sensors. They can also carry, there is a hand-like manipulator. Using this manipulator, you will be also able to pick up samples from the seabed and collect them in a bucket or something like that for studies. This expands our knowledge of the oceans and make better understanding of the ocean floor and various water columns. They also are used for looking at the debris and the sunken ships and many other things. So these are advanced tools available at our disposal today for understanding the oceans. So what you see here is the manipulator that is attached to the ROV, picking up a sample from the seabed surface. It's a crust actually picked up from the surface. When we collect it to the laboratory, we'll be able to do analysis to understand what kind of material these are made of that there are any interesting minerals which are available in that location and all that. These are studies that can help in our understanding of the seafloor. The various kind of collections from the seafloor using the ROV systems. The thing is that we know where we are standing on in the ship, and we know where the ship is standing, and using this information and what is available on the seafloor, we are able to map the seafloor and see, okay, these are the resources available in the seafloor, these are the history available in the seafloor. It is expands our understanding of the seafloor. And today we have various tools available in the seafloor in our ships to do all these things. What you see here is a winch which carries an electrical and signal cables and fiber optic cables together to connect with the ROV system, and we are able to directly see, sitting in the lab, as this equipment is sent down to the bottom of the seafloor, we are able to see the water column and the seafloor characteristics. I'm not showing very detailed hi-fi videos here, which are today available to everybody in National Geographic and Discovery channels and several other resources. So, but these are the fundamentals over which all these things were built on. So I'm touching upon these subjects only for the students for a tiny understanding of what happens in oceanography. Subsequently, the interesting videos and things like that, whoever is interested to study further, they will be able to go into this further in their colleges and in their free times, leisure times, and expand their interest and understanding of the latest technologies for understanding the oceans. Subsequent to the other samples that I have shown you, these are aerosol samples. which are an array of filters. It's a mechanism fitted onto the ship, and we operate this continuously to collect air sample and filter it through the filters. And these filters collect all the material that are floating in the air, and these are actually connected with the data buoy data that we get it, and then we can understand what is floating around in the air above the sea, and what is their impact to what is settling down, and what is the biological species that are getting as food, and the movement of various particles in the air that is traveling around and affecting everyone's lives in the earth on the land area. So these are called impactors. They collect air samples from the air wherever the vessel is moving along, and this is another important tool in the hands of scientists to understand what happens in the atmosphere above the water level that is affecting the water below the ship and in the region. That is, with that, I cover the entire understanding of the, as I said, a nanoscale understanding of the surveys and samples. What I show you here is the various vessels, research vessels available in the country for carrying out all this research, oceanographic research. What you see here is Samudra Ratnakar. She is a research vessel working under the Geological Survey of India. And what you see on your right is ORV Sagar Kanya, which belongs to the Ministry of Earth Sciences. These research vessels are fitted with a lot of state-of-the-art equipment for collection of seawater characteristics and seabed characteristics and several other studies that any branch of science that you undertake that relates to the oceans. All these research vessels aids in our better understanding. What you see on your left is the ORV Sagar Nidhi. She's a technology demonstration vessel. A lot of technologies are being developed in National Institute of Ocean Technology, and these technologies are this vessel is used for using these technologies, testing these technologies, and then once the technologies are ready to demonstrate to others what our scientists can do in the ocean. So she has been doing a very good job in doing this activity. We use these vessels extensively for oceanographic research. On your right is the Fisheries Oceanography research vessel, which carries all the equipment for various collection of fishes from different parts of the Indian Ocean and other area related to India. And we collect both biological species as well as fish samples at different time of the year and from different depths of the ocean. And these records help us to predict and forecast what is going to be available for us in the future as a food resource. And she has been doing an excellent job in collecting this data and then providing input to the scientists for understanding this activity. What you see on your left is the buoy deployment vessel. I've shown you a data buoy, which is we have deployed a lot of data buoys. The government of India's resources are around the ocean in Bay of Bengal and Arabian Sea. This vessel is being extensively used for deployment of such buoys around the ocean and monitor them and carry out maintenance and things like that. On your left is another new research vessel belonging to the National Institute of Oceanography, and she also is capable of carrying out all the research, multidisciplinary oceanographic research. There are two new childs in the ocean belonging to India. Sagar Anveshika and Sagar Tara are coastal research vessels which are used for carrying out oceanographic studies in the very close to the beaches and shores. And these are small vessels, but carry a lot of state-of-the-art equipment on board for ocean research. And these were very young vessels, just launched a year ago. And these are all available as tools to the interesting future generation to study the oceans and then connect them with our livelihood in the future. As I said in the beginning, oceanography as such is a very vast subject. We at Norinco, we work with all the scientists in the country and also with many scientists around the world to better understand these oceans and provide the input to the scientists. Our team of engineers are always on board these vessels that I have shown you, 24/7, helping the scientists to collect data and collect samples so that the scientist is able to spend his time on taking the science forward. And we are there all the time to help in this activity. This is our activity, and this is how we have contributed to the science for the last 25 years, ever since we joined this group and the first oceanographic activity from Norinco Private Limited. Even though I have been connected with the oceans for the last 38 years now, so you are able to, this is what I will be able to contribute and take it forward for the future generations in expanding this understanding of the oceans and sampling activities and sciences. As a company, we do have, we continue with our development of various equipments and design of various equipments and that are used in the operations that I have explained just now. And we do invite the students who are interested in pursuing oceanographic science. They can have some trainings and involved in the activities, and we will be able to help them. And as Mr. Nanda Kumar has explained, we'll be able to take some of you students as interns for giving an understanding of the techniques involved in oceanography. Thank you very much. That's all I have here. Thank you, MTS, Dr. Venkateshan and Nanda Kumar and everyone else in MTS for the opportunity. And thank you all.
Thank you, sir. Thank you for sharing your valuable expertise, and it was a great presentation, sir. So now we have a few questions from the students' side. So I would like to read the first question. How they deal with noise in underwater survey? Acoustic noise is there, or like due to wave or air, or due to bioacoustic sound?
All of them create noise, but when we use this equipment, they are tuned to a particular frequency, and we send the sound pulse in a particular frequency and then listen to that particular frequency to come back. All other bio noise and wave noise and several other noise, they are spectrums. They are actually a mixture of all kind of noise, whereas we take some particular frequency noise and send it down and get it back. So that is how we are able to collect this data. Actually, when I explained the multi-beam echo sounder, there are an array of sound noise with a specific frequency for each of the pulses. We send it with a slight variation in each of these pulses, so that each pulse carries a signature of what we are sending, and we look for that signature when they come back, and then take that noise for analysis. That's how we are able to map the ocean very quickly. Acoustics is very vast science. In fact, most of our equipments that we use in the ocean, they use the sound as the source for the understanding. So there will be much deeper studies required. This is the gist of how we use the sound in the ocean for data collection.
Okay, thank you, sir. That question was from Roshan Singh. And another question from Munazir Fatima. She has asked, how is the sound of wave is calculated?
Like I said, it is the listening post that we can create noise recording units which are attached to the buoys at the bottom of the buoys, which are actually receivers, microphone receivers, that can collect the noise. As I said, it is not just the waves. There can be all kind of noise that you will get it, and further analysis only will tell you what kind of noise it is. We have to do a lot of data collection to analyze this noise and then identify the source.
Okay, thank you, sir. And last question from Preeta ma'am. In Fisheries Survey, what are the recent technologies used to understand the fishes count and their survival, and how it is beneficial to fishermen?
Like I said, again, there are different type of acoustic equipment which are available in the fisheries research vessels, and these fisheries, acoustic equipment, like there is a sonar which will be able to send a beam of sound and then get a reflection from the fishes to identify what kind of fish is there, and whether it is a single fish or whether there is a school of fishes. And these reflections can give a lot of information about what is available in the sea. Subsequently, we also deploy the net with a different type of mesh sizes to collect a particular kind of fish. If it is a small fish, we are able to send a particular type of net. This net also will carry sonars in their mouth, so that we know what kind of fishes are getting into the net and what we want to avoid from getting into the net. We can filter out this type of species from the collections. And this data is again taken to the lab for further analysis. We collect this data on a time series, like every monsoon or every March, you go to the particular region and then pick up this data. That is how you carry out the survey and understand, okay, what is available. These ships are always busy collecting this data, and looking at the variations, we are able to identify what type of fishes are available in which region, when, and what is the type of, when you are required to fish them out and then use it for your food, when you should allow them to live there as juveniles, so that they can grow to a level when you can actually go and collect them, fish them up and collect them in the net. So there's a full-fledged scientific team in CMLRE, Center for Marine Living Resources, set up available in Cochin, which is doing this research. And these scientists actually carry out these surveys, and then continuously for years they collect this data, and they come up with a map at the end of the year to tell you what is available, when you can go and fish them, and what are the tools available to do this science. All these acoustic things, we also collect the ground truth using other equipment I have explained to you just now, with the nets and things like that, and you'll be able to align them. Okay, this is the sound that is created by this particular fish. To better understand all these things, you'll be able to study these things. So that's how we can proceed.
Thank you, sir. Thank you so much. And we have questions from students asking for sir's contact details. So I have given sir's mail ID in the chat box so that everyone can see. It's rajaraman@norinco.co.in.
Yeah,
And
please send your queries, and we will be able to give you the answers, or direct you to the source where you can get additional knowledge on these subjects.
Thank you, sir. And other questions regarding the membership to MTS, and I've shared the link of MTS HQ. You can go there and register. If you have any doubts, you can always mail us to mtsindiasection@gmail.com. And now I would request MTS Chairman, Dr. Venkateshan sir, to felicitate our resource person with a memento.
Thank you. We can only handshake virtually.
Soon we'll hand it over to you personally, sir.
Thank you.
So much. Thank you. Now we are entering into, thank you, sir. Now we are entering into the next part of the session, which will be carried out by Dr. J. Preeta Roslin, who is also the student coordinator of SRM MTS student section. Just a minute, sorry. Dr. J. Preetha Roslin is working as an associate professor in the Department of Electrical and Electronic Engineering in SRM Institute of Science and Technology. Her areas of specialization are voltage stability, computational intelligent techniques, evolutionary computation, grid integration issues of renewable energy, building or automation. She has published 30 international publications, 30 conference publications, and 1 book. GA-based placement of fax devices for voltage stability enhancement, GA-based coding, Lambert Academic Publishing UK. She has received DST funded project and SRM seed project. Now I would request ma'am to start the session.
Hello, ma'am. You can unmute yourself, ma'am.
Yes, good afternoon, one and all present here. So I welcome you all. I welcome you all for today's webinar session in the practical session of machine learning. So this machine learning is a platform in which all engineering disciplines can use it. The only thing is their application varies. Reminding all is the machine learning tool in which you have to implement for your particular application, and you can mine your data in which it is available. So let us have a very quick review about the machine learning, and then we'll go for a practical session in Matlab, how to implement a basic machine learning in Matlab toolbox. So in this particular coding, you can use it for all your applications. Only thing is you have to change your data set which your application is specified. So if we think about the machine learning algorithms, is my voice is audible?
Yes, ma'am. Audible, ma'am.
Yes, ma'am.
Okay, so machine learning is a collection of techniques for extracting information from the data. This is what the basic information that we get. So what the machine learning algorithms does is it learns the information from the data without relying on any conventional models. So the machine learning algorithms, it finds the natural patterns in the data and helps us to make better decisions and predictions. So what is the difference between a machine learning model and a conventional model is, in conventional model, you have to think of equation by yourself, how the model works, but lot of real world problems are so complicated to work. With machine learning, you build the model with the data itself, apply machine learning to real data, and let the machine learn from those examples how to map the input to the desired output. So what is the process of machine learning is, first thing is you have to import your data set. So it can be an oceanary data, it can be a battery data set, or it can be a complete intrusion data set in which you want to work out with. So import your data set, and then you organize and pre-process your data set. So what does it mean with organizing and pre-processing means? Your data set will be a raw data set in which the machine learning cannot understand very set. The initial point is the data set has to be divided into two aspects. One is a training data set, another one is a testing data set. After that, you go with building a model. And when you build a model, you have to process your data set in the model. And then the model has to be evaluated in real-time applications, how it is working in real-time data set. And then you deploy the model for the usage. So basically, machine learning is being divided into two categories. One is supervised learning and other one is unsupervised learning. So what is supervised learning is, It learns on an unlabeled data set that algorithm evaluate on training data. In unsupervised learning, it provides information on unlabeled data that the algorithm understands by extracting the features and patterns on its own. So when you consider the unsupervised learning, we can do clustering in that. So you can see this graph in which any data set comes, it clusters, it forms clusters with the data set. So it learns the data set and it forms clusters or groups with the data set. And in supervised learning, you have two classifications. One is a classification problem, and other one is a regression problem. In the classification problem, if you can see, like there are red colors and blue colors and green colors in your graph. So what is understood is whenever the problem comes for a classification, the algorithm develops first a particular group in which it classifies the data set and it groups together. So when an unknown data set comes, so if you can see this particular dotted line in which you have blue, green, and red colors. So this identifies which it is nearer to the which particular this green color is closer to the green group. And then if you see the blue data set, that is very closer to the blue group. So in that way, it identifies and classifies the data. When you go to the regression problem, what it does is you have a linear line in which whatever the data that comes, it fits in along the linear platform. So your problem, whenever you're choosing a problem in engineering applications, you may be able to cluster the model. You can go for a classification model. You can go for a regression model. So in classification model, whatever the data set, you can classify it. So whenever it comes, it is very severe, or it is a moderate data set, or it is a less severe data set, you can classify it. Regression means it can tell you a time series data output in which in future, what is going to be my particular value, in which I can tell you an example for load forecasting. So in load forecasting, what is done is the future demands in the power systems are being identified using the regression model. So we can see some of the applications of machine learning in which today's world are totally crazy about it. In autonomous driving, image-based machine learning model play a vital role for self-driving cars to detect the objects in the images. Machine learning model allows the cars to collect the data on its surroundings from cameras and other sensors, interpret it, and decide what actions to be taken. So this is the most current application in which machine learning is being used in autonomous car technologies. So I'll go for one particular application in which I have implemented the machine learning for smart building. And that application is for occupancy detection. So what is done in occupancy detection is human occupancy inside a particular area is being identified. So what is done in this particular graph is there is a sensor called thermal sensor in which that is deployed in the room, and the person sitting in particular segments, that sensor is able to identify the person based on its thermal vibration or thermal radiation coming out only from the humans. So thermal sensor is very different from your temperature sensor, in which thermal sensor identifies the temperature irradiance coming from the human beings alone. So it is effective than your temperature sensor. And what does the machine learning model does is whenever the human occupancies are present in a segment, the camera captures the images and the machine learning model identifies the human occupants. The remaining objects and all discarded, and only the human occupants are identified. And based on that, you can switch on and off the electrical appliances, or you can control your HVAC system, etc. So in this case also, a particular person is being identified as static. So here you can see dynamic movements. The persons are moving here and there. In that case also, it is able to detect the human beings. So based on that, if human beings are present in a particular area, the illuminance of the room, like light irradiance, the cooling of the room, everything is being identified based on the number of occupants in a particular segment. And based on that, your appliances are being totally controlled automatically in your smart buildings. So what is happening is without a human presence, this platform is being done in a LabVIEW-based software in which the hardware is being interfaced with the image processing toolbox, and then your human occupants are detected and the corresponding segments are alone activated. So whenever you get the green signal, it is understood like the human occupants are identified in a particular segment. So this particular machine learning model for the occupancy detection has been compared with many of the existing technologies. Like there is a technology called only with thermal sensors, only with image processing algorithms, only with PIR sensors, and the proposed algorithm for machine learning for human detection. It makes your detection of humans very closer to the ground truth, and it avoids many errors, whichever is happening in the remaining algorithms. So this is a very basic, this is an application in which the people are doing for smart building technologies, for controlling the HVAC system, for controlling the electrical applications, for emergency navigation system, etc. So let us move on to the very important topic, like how to implement practically a machine learning tool in Matlab. So what application I'm going to choose today is, we are going to do for two applications. One is character recognition, and the second one is the tool which we have to implement is a flower data set, in which it identifies the flowers based on its features. So that particular tool, the participants, if you have Matlab in your particular in your laptop, you can open it. So whenever I'm going to tell you the complete code in order to implement a basic machine learning tool. Once you identify that toolbox itself, you will be able to understand the advanced machine learning tools also. So here, what is the first thing is for character recognition. So the question is, what is the importance of character recognition? Character recognition provides persons who are blind or visually impaired with a capacity to scan the printed text and then share it in a spoken and a synthetic speech or saved in a computer file. So character recognitions are very important, in which you just send some symbols in defense purpose and all. They'll be having some secret symbols in which they'll send it to the corresponding destination. And in the destination, they'll try to figure out the characters behind the text symbols using the machine learning algorithms. Or in other cases, it is very important for the blind people or visually impaired people to understand the text, what is written in every tab or in textbooks or whatever it is. So let us start with the session. The first one is, first thing is you have to import your data set. This is what the first process we studied in machine learning. So here, what is our application is, many people, let us, for an example, they are writing a particular character in a tab or in a particular phone. So whatever it is, or in a notebook, the character is being written. So now the algorithm is going to identify, or it is going to classify the characters. So let us see, you have 3 characters written by human beings like J, M, and V. Now what we are going to do is, we are going to train our machine learning tool to classify these characters, and it is going to say like what character it is. So without any human intervention, that algorithm itself will identify what character it is. So for that, what is the data set we have is, this is the data set. How does the data set look like is, whenever you write the character, you have X parameter, you have Y parameter, because you have an X axis and you have an Y axis. So this particular data set is having, the first one is your timestamp. So timestamp tells you at what time your character is being written, and X is the variable and Y is another variable. So horizontal parameters and vertical parameters. And the last one is the pressure in which the person uses to write that particular data set. So that differs from human to human. Even X and Y also differs from human to human handwriting. So this is a complete human handwriting in which you have X-axis, Y-axis, and the pressure that they use for writing that particular character. So now, what is the template that you have to use for importing your data set is, letter is equal to read table m.txt. So this is a text file which I'm having. So what I'll do is, after this particular session, I can share you some of the text files and basic codes in which you can try with the data set. And after that, when you get your application, you can import your own data set and study the problem. So m.txt is a file. It's a text file which I'm having, in which all the characters in this particular text file refers to M. Similarly, I have a text file for J and a text file for V. So what is the syntax that you have to write in Matlab is read table m.txt and let it be stored in a variable called letter. So now the next point is, when you have imported your data set into a variable, you have to plot and you have to visualize your data set. So what is the syntax for plot is plot letter.x comma letter.y. So because letter is a variable in which you have stored your data set, so x comma y. So when you type this particular syntax, you will get a graph like this, in which this is one particular person's handwriting of M character. Next is the correction of distance units. So why this particular correction is needed is, when you're writing your character in a tab, let us assume like your character which is written on a particular device, it's not a square device in which the horizontal is having 15 inches and the vertical is having 10 inches. So in this case, you have to correct your distance, in which the horizontal units, you cannot take it like 0 to 1 and vertical also 0 to 1, because here horizontal is 15 inches. So I should adjust my range to 0 to 1.5 instead of 0 to 1. So this 0 to 1 horizontal axis is now has to be adjusted to 0 to 1.5. So what is the syntax for that is, you need to adjust your x variable alone. So multiply your letter dot x into 1.5. So that is what the adjustment. Multiply that corresponding column with 1.5 and store it in a variable called m. Right. So now you can replace this m in letter dot x. So you can see the data set. The remaining y and p are not disturbed, and only x is being multiplied with 1.5, so that you get the x variable to be, that is the distance of units is being corrected to 15 inches. Now the next point is, you can see the x and y axis. Now the x is being corrected, but even after correcting that particular x, the distance ranges are not equal. The axes are not equal, because you can see here it is 1.1 to 1.12. The difference is 0.02. But here if you check, it is 0.01. So y-axis is having a range difference of 0.01 and it is having a range difference of 0.0. So in that case, you have to adjust your axis. So what you have to do is, we need to adjust our x-axis. So how to adjust our x-axis is, just write this in. So whatever I have written it in green color, that is a MATLAB code. So even you can have a quick review of it. Whatever is written in the green color or the MATLAB codes. So when you type it as axis equal, automatically the axis is made equal. So now you can see all the y and x axes are being made equal. That means the difference between the. So what is the next step? So you have imported your data set, you have processed your data set, you have visualized your data set, and now you have to normalize your data set. So what is normalization is, the first thing is you have to determine about the timestamp. What is a timestamp is, it represents the number of milliseconds from the start of data collection. So whenever the person starts handwriting or writing that particular character, that's what it represents a timestamp. But what we want is, we need like at what starting the person what we need. So you may have a doubt like, this doesn't look like M character because you have processed this character. Initially, you had the character like this only. So when a person is writing, you after adjusting the distance units and after making the axis equal, it goes with the graph looks like this. So this is not even though it doesn't looks like the M character, it has made, we have made the axis to be equal. So now the raw data is now being processed to make the tool to understand. So now what happens is, when you type the command axis equal, the axes are made equal. So when you are normalizing it, what we have to do is, when you start with the time, so letter dot time is equal to, from the initial time to the first time the person starts writing. So what letter dot time initially is, The time you start collecting the data set is what letter dot time. What is letter dot time of 1 is when the person starts writing the character, that is letter dot time 1. So we need not need the timestamp from the beginning of collection of data set. We need only the time when the person starts writing that particular character. So you can subtract those two and you have to divide it by 1000 so that the timestamp is being Now the next is you have to, how you had for x-axis and y-axis. Now what we can do is let us plot x versus time and y versus time. So this is what the syntax for that. So when you use that particular command, the x-y axis is now splitted into two graphs, in which one graph tells you about the horizontal position versus time, and other graph tells you about the vertical position versus time. Now the most important step in machine learning is extracting the features in the data set. So what do you mean by features? Means it is a very useful information from the data set. That's what we call it as features. So whenever any data set comes, we should first understand what are the features available in the data set. So here we can say the important feature for this character recognition is the duration of the signal. So it is the starting of the character and ending of the character. So that is very important. So when you see from this particular graph, both the vertical and horizontal positions end at a particular time, at the same time. So that is what we call it as duration for writing that character. So first thing is why this duration is very important is when you think about the character A. So it's very tall and narrow. J also when you write it is tall and narrow. And when you think about M, it looks like a square. So the duration, the time that is taken for writing that particular character is what we call it as duration. So that differs from character to character. So because we are going to do character classification, right? So duration is equal to what is the axis? Letter dot time of end. So why end is written? Because at the particular end at what the character ends. So duration tells you a value at this particular character ends. So this also differs from person to person. Next one is you have to visualize your extracted features. So what are the features that we are going to do is the first feature is the aspect ratio. The second is the duration. And what is the output? Output is a character, whether it is J character or M character or V character. So if we think about the aspect ratio, we know that aspect ratio is the relative length of data along the axis that you have studied in mathematics. So that is the same aspect ratio only. So when you think about the aspect ratio, we need to think about the range. So what is range? Range is nothing but maximum of x minus maximum of y. That's a formula. So this we have to do, and then we have to find the ratio. When you find the aspect ratio, it's nothing but range of y divided by range of x. You get the aspect ratio. So this is a very important feature in the data set. So the two important features in the data set are aspect ratio and duration. And the output is the algorithm will tells you the character correspondingly. So here this data set which I'm going to tell you is having 470 letters written. Whatever the features you have identified now, load the feature data in the Matlab code. So you have to write the syntax load feature data.mat. Next is when you type it as features, immediately your complete features will be displayed. That's what it is, features. So what is understood is initially you had an image and now that image is being processed and you have extracted only the features. So we are going to now process only with the features and not with the data set that you have. So now plot your extracted features. So when you plot your extracted features, you have to use this command scatter. What are the features we have? Aspect ratio is one feature and duration is another feature. So scatter is just a command for plotting the features. Type in the code, you get a graph like this in which the features are all plotted in the graph. So it is understood like I cannot understand anything from this particular graph because all looks very similar. So there is another command called gscatter. What is gscatter is? It is a group scatter plot. So that looks like I have 3 characters in my data set. So it plots, it gives colors to each character like red for J, green for M, and blue for V. So you can see like the characters are being grouped together and it is classified now. So 470 letters written by the people are being grouped. What addresses? These are the outputs of different classification algorithms like KNN or deep learning model, or it's a regression model, something like that. So every different algorithms, machine learning tools will give you different outputs. You can see here in this particular model, here the blues are all being colored, or it is grouped like one classified, and green is classified and red is classified. And in the second algorithm, even it is able to see some blue dots in the green groups. So the algorithm is able to identify that blue dots, and it is classified along with the blue groups. And here this is a much better more algorithm in which the blue are all completely classified in blue groups. So now let us go with a classification model of KNN. So KNN means K nearest neighbor algorithm. So this model, let us try for the classification tool. So you may have a doubt like how to use this model. It's very simple. This model is already being inbuilt in Matlab toolboxes. So simply you can type it like fits CKNN. So this is what the syntax that you have to use when you want to use a KNN model. So KNN model is equal to fits CKNN features comma character. So when you type this particular syntax, the KNN model starts opening. So KNN is a complete classification model that we are going to use now. So once you build the model, so what the syntax tells you is you are building a model. So just by typing this line, your model is built. After building the model, it can classify some observations. Next is I need to predict my data set. So predictions. So what does it mean? I told you we have 2 data sets. One is your training, another one is your testing data set. So using the training data set, you have to train your machine learning model to understand about the data set. Using the testing data set, you have to give it to the model, and the algorithm will tell you what is the output. So in your training data set, input, output, both labels will be available. And in your testing data set, only input will be there and output will not be given. And machine learning model will tell you the output. So this is what the code for predicting the outputs. So predictions is equal to predict KNN model comma test data. So now what I'm feeding the test data to the KNN model. So when you enter this particular code, automatically the outputs will be displayed like this, because now for every, I'm just testing with 8 data set in which my algorithm tells me like what character is first one, second one, third one. So it automatically displays the character. So when it happens like that, you can see in the graph, right, some are outliers. So outliers means they are labeled in a wrong way. So you can see like when it is grouped blue or in the nearer to the red groups, and red is there in the green segments. So these are called as outliers or false detections. So if when our model is very sensitive to outliers, what will happen is some new observations near the outliers also will be misclassified. So we have to make our model less sensitive to the outliers. So my model should not be more sensitive to the false detections. So what should I do is I should increase the value of K. So in the KNN model, where it is the same code, same syntax I showed you, there is a thing called number of neighbors. So whenever I choose this particular data, I will see like what are the neighbors there. Okay, so if I make my neighbor to be 1, it checks, okay, red is the nearest neighbor, so it classified to red. So my algorithm is very sensitive to the outliers. So what should I do is number of neighbors, if I make 5, it goes on increasing with the 5 nearer neighbors, and it identifies, oh, this is very closer to the blue and not to the red. So my algorithm is able to interpret the outliers, and correspondingly it labels it. So you have to make the neighbors increase the value of K. Now again, when I type the same command, so this is the same command that we do for in the previous step, but now I have increased the neighbor's value to be 5. So again, type the same code. So what happens is now when you predict it, what happens is these are again the syntax. So first one is I'm going to concatenate my arrays. What is concatenation is? This is what the prediction my machine learning model has started. That is a KNN model. KNN model has started with the prediction data set. And this is what the data set which I am having in my hand for checking. So for validation. So when I check, how I'm going to check, because this is a very small data set which I can check immediately. But when you go with the huge data sets of lakhs or thousands of data sets, how I can compare every data set, whether my KNN model, what it has predicted is closer to the truth value, ground truth value or not. So what is the command that we have to type is correct is equal to predictions is equal to test data. When you type this command, what the command will fetch you as output is whichever character is closer to the ground truth, it returns you 1, and whichever is not equal, it returns you 0. And some people will always be very curious in identifying the misclassification. So they'll make 0 entries as 1 and 1 entries as 0. So here, what is the only change you have to make is instead of equal to, you should put not equal to. So what are the performance parameters that one can study with the machine learning tool is, one is accuracy, another one is a misclassification rate. What is accuracy? It is a ratio of number of correct predictions to the total number of predictions. Is the number of correct predictions to the total number of predictions that gives you the accuracy rate. What is misclassification rate is the number of wrong predictions to the total number of predictions. So for this problem, your misclassification rate is 0.2 and accuracy rate is 0.8. Now, what is a confusion matrix? This is a very common thing that people will do with the machine learning algorithms, that they will identify the confusion matrix. So what is a confusion matrix tells you is, if you want to see the confusion chart for your data set, you should simply type this command as confusion chart test data.character, predictions. So test data is your validated output that you're having in your data set, and prediction is what your machine learning model has given you. So when you see this confusion chart, this is a ground truth, and this is your predicted output from the machine learning tool. So it tells you JMV, and here also it is JMV. So here you can see four particular labels are correctly identified by the machine learning tool, and 3 are being correctly identified as M, and 1 is being correctly identified as V. But if you see the remaining things of 1 and 1, this one and this one, M is being wrongly misclassified as V, and V is wrongly misclassified as J. So this is what we got a misclassification rate of 0.2. So this confusion chart tells you very clearly about the accuracy of the algorithm that you are implementing. So now next is, we can go with the complete code for machine learning in Matlab. So I'll directly open my machine learning code, Matlab code, and I can explain you. Before that, I'll tell you about the data set. Okay, so if you want to tell about the machine learning tool, next algorithm that we are going to see is the artificial neural network, which is basically depends on the perceptron model. So perceptron model is how to interpret the perceptron model in Matlab is, this is what the code. Net is equal to new P, PR, S, TF, LF. What is PR is? It is a minimum and maximum value. You can see the sample commands. You can just have a snapshot also. You can type in your Matlab and you can check. So the sample values of minimum is 0 and maximum is 1. So that we have to type. And next is yes. Yes is number of neurons. So I think you're all familiar with the ANN model in which it has input layer, hidden layers, and output layers. So in all the layers, you will have neurons for processing. So I didn't go very in depth into the ANN architecture and all, because we are just focusing on the machine learning implementation in Matlab. So there are a number of neurons in every layers. And then what is the transfer function that we are using and what is the learning function that we are using. So this is what the syntax for creating a perceptron model. And when you after creating a perceptron model, you have to train your algorithm for a particular goal and for a particular iterations. So here I have made my iterations to be 20 and goal is 0.001. What do you mean by goal is that is the difference between the predicted value and the ground truth. So that we take it as 0.001. And then you have to use the function train to train your network, because every algorithm, it has to be first trained with the trained data set and then only it can be tested. So what is the code is net is equal to train net comma p comma t. And next is you have to simulate your network. So it is sim net comma p and store it in y. This is what the output you get in y. So instead of going into the PPT, we can directly see the coding. Yes, is my Matlab code is visible to all of you?
Yes, ma'am. Yes.
Okay, so this is what the first code that we are going to study about today. And we can share this code also to all the participants.
Sorry for interruption, ma'am. So that they can use Matlab grading also for this to check in online, ma'am. Is it possible, ma'am?
Not in grader, they can go for Matlab online. They have to type Matlab online and then they can use the Matlab.
So participant, we request to use Matlab online software. You can directly type it as Matlab online in Google Chrome, so that you can able to use this coding as a live training session.
Yes. So first I'll tell you about the data set, then only you can see like what is happening in the data set. Yes, for today's case study, we are going to take a data set for iris flowers. So like this, you can have any classification model. So there are 3 flowers in which you have to classify the flowers. That is the challenge for the machine learning tool. So now the 3 species are there. So like this, in biomedical applications, what they will do, they will have a particular classification model for identifying the different genes or different biological changes like that. And in electrical applications, you may have a data set to classify your load pattern, like whether what type of customer they are. And in terms of electronic applications, you can have a data set in which you can identify the signals. You can classify the signals. So like this, for every platform, if suppose you are a mechanical engineer, you can go with the data set of classifying your machines based on its signals, based on its electrical signals that receive from the machines. You can identify the signals. You can classify the signals, whether the signals are correct or it is inaccurate, something like that. So here the data. So for us, we are in the stage of understanding what our machine learning is doing with the classification algorithm. So let us see the 3 classified flowers. So now I'm going to classify the flower in 2 parts. In every flower having a petal and a sepal. So length of the sepal and the petal is what the feature that we are going to extract from the data set. So you can see a sepal length, sepal width, petal length and petal width. So it varies. So you get for one flower, if it is given to the toolbox, it first you're giving it in numbers about the length, width. Similarly, this is like second data set, third data set, like that. You have n number of data sets. Now, what is our output class label is? One corresponds to one flower, second category corresponds to another group, third category belongs to third group. So if your machine learning tool is giving you the number as 1 means What is a flower? It is setosa. If it is giving us 2, the label is 2 means it is classifying it as versicolor. If it is given as 3 means you have to classify into virginica. Right, so this is what my data set looks like. So this is sepal length width, petal length width, and it tells you the last one is your output class label, whether it is 1, 2, and 3. So how does your output will come is, if you are giving a setosa flower, then your machine learning tool will give the output as 1, 0, 0, and versicolor means it will give 0, 1, 0, and virginica will give you the output as 0, 0, 1. So let us see the Matlab code now. Yes. So you can see the code now. I will just type here what is what line represents what, so that the participants can understand what is happening. So what I am typing, I think you'll be able to see that. So first one is I am in the line of load iris data. So what I'm doing, I am importing my data set. Right? So this is what the command for importing the data set. So you have to see where is your data set. So here is your data set. So this is what I have my data set here. This data set, you can download it from net also, because if you are a starting practicing engineer for machine learning, you can download this data set in Google. Like this is sepal length width, petal length width, and this is the corresponding output of whether it is 100 means it's the first flower, 010 means it's a second flower, and 001 corresponds to the third flower. So output of the machine learning tool will come as a binary number of 001 or 010 or 010. Okay. So now let us go to the code. So in the code, after loading this iris data, after loading your data set, what we have to do is we should store this data label in a particular variable. So just see what I'm typing. Store it in a variable. Right. What is the next step is, you have to discriminate your inputs and outputs. So what I'm doing is the first 4, you can see here, there are 7 values here for every data set, but first 4 refers to the input and last 3 refers to the output. So first 4 is your input and 5, 6, 7 are your output. So what we are doing, the total XY data set, I'm just making the first 4 entries to be stored in X, and 5, 6, 7 values are being stored in Y, so that I have segregated my input and output values. Now what is my next step is, from the same data set, I should divide something for training and some for testing. Okay, so when you do the testing, when you do the training, you're training your model for this particular application. When you're doing testing, you are validating your model. So once it is validated, you can deploy in real time for using this particular application. So what is this line is? This is testing input data. So what I'm doing, X is the variable in which inputs are stored and Y is the variable in which outputs are stored. Now what I'm going to do is, from the complete X, that is the input vector, I'm going to select 1 to 2 to 150. So I have totally 150 data sets. In that, I'm going to select second values till 150. So that I will make it and store it in X2. And what is the next column is testing output data. So in Y2, I'm storing the output data for testing. So in the total X and Y, I'm just removing some for testing my algorithm, and that is stored in X2 and Y2. Now what I will do is, as I have taken those X2 and Y2, I should make values in X to be a null vector. Then only it gets cancelled in what? It is something like deleting that corresponding column in your X variable. So remaining I can for the training data. So this is removing test data from the input. So whichever I have selected for testing, I am removing from the total label. I think when I type the command, you'll be very able to understand what is happening in the syntax. Now, what is the next step is, whatever it's remaining now in X and Y, because I have selected something, I have selected 75 for, if you check the number, you'll get 75. So you have taken 75 for testing. The remaining values, whichever you have it in X and Y, that you store it in X1 and Y1. So this is what the training input data. And this is the training output data. So we can see like X2 and Y2, you have the test data, and X1 and Y1, you have the training data. Now, what is the next step is, we have seen the next step, it is normalization. So these are the normalization process. Whatever I'm just commenting, you just check it out. The thing which I've highlighted in blue, no, that is what the normalization procedure that you have to do. So it's nothing but X1 minus minimum divided by maximum minus minimum. So I have to normalize all my parameters, that is X1, Y1, X2, Y2. Okay, you have segregated your complete data set into 4. One is X1, one is Y1, other is X2, another one is Y2. So you can see the code, it's all repeated thing. So whatever it is written is the normalization. So you can see this one, this is a normalization for X2. You can see this is a normalization for Y1, and this is for the normalization for Y2, right? So normalization is done. So first thing is, you have imported your data set, you have divided the data set into training and testing data set, and then you have normalized your data set. Now we can go for building our model. So this is build the model. So what model I have choose is feed forward neural network. Okay, so I have choose a feed forward neural network in which the training algorithm that I have used is a Levenberg-Marcadet algorithm. So there are many training algorithms are there. So depending on the application, you can choose your training algorithms and you can test like the model works in which particular training algorithm. So this is net is equal to feed forward net 20 comma train LM. So that tells you, that fetches you the feed forward neural network. What is the next step is random C comma 0. What does it tells you is, my algorithm will not stop in a particular point. It searches a value everywhere, so that when you type this, it goes on with the searching point. Next is, you can see the highlighted points. What is this is? It's weights and biases. So if you have seen your machine learning architecture, between one layer to another layer, you may have another parameter called weights and biases. What is weight is? Weight automatically adjusted during the training function for a specific learning rule to get the desired output. And bias means it is a shifting action from left to right for successive learning. So any model, it needs some weight and it needs some bias. So weight means from one layer to another layer, there will be a connection. On the connection, some weight will be there. So what does the weight does? It makes that particular training function follow a certain procedure. And what do you mean by biasing means? It shifts the learning function left to right so that you have a successful learning. So that is what biasing. So this is what done in this particular commands for weights and biases. It's initializing the values of weights and biases. Now after that, net is, so I can write here, this is what weights and bias initialization. Okay, next is you have to initialize your algorithm. Right, so you have to start your algorithm. So that is in net. So already I've stored your model in net. So I'm going to start my algorithm. So next is I have told you already what is epochs and what is goal. So epoch is the iteration and goal everyone knows. So I can simply write it as goal. So yeah, you're going to set a goal. That is the difference between the predicted and the actual output is 0.01. That's the error. That is what the maximum error I have in my model. So that is my 0.01 and 1500 iterations we are having. Now what is the next step is you are going to train the model, right? So when you train the model, so what is the training data set we have stored? X1 and Y1 are the training data set. Why it is written X1N, Y1N? Because you have normalized it. You can see here Y1N, X1N. So your normalized values are now in X1 and Y1. So train the model using this particular syntax, train of this. Okay. And next one is, what is MSE TRS? When you are training the model, you can calculate the error in training model. When I'm training the model, I have to be clarified whether my data set is sufficient to train the model. So sometimes the model will be overtrained using the data set which is not needed. And sometimes your model is undertrained. It does not identify the complete data set so that you cannot implement it in real time. So you have to identify when you train the model whether your data set is sufficient to train your model. So you have to identify the error in the training model. So what about this? So whatever weights and bias you have initialized that we are using now, implementing weights and right. So that's what done in this W1, B1, W2 and B2 between the layers. Now the next step is I'm going to simulate my network. Simulate the network. So what is simulating the network means? I have to use the command sim. Again, my model is stored in net. So comma x2n. So why alone x2n? X2 alone is given, y2. Y2 is not given means when I'm training the model, I will give both the input and the output labels. But when I'm testing, so now is my voice is clear?
Yes, ma'am. Yes,
Okay.
now.
It's something was missing in the beginning.
No, ma'am. It was suddenly there was some noise, ma'am. That's
Okay.
it, ma'am. No issues, ma'am.
Okay, so after simulating, when you're simulating the network, this is what the syntax that you have to do. So I'm storing my output in Y. So I have to give only the training input value and not the output value. So now your machine learning model knows only the input and it doesn't know the output. So who will give the output? Only a model can give the output. So we are asking the model with the input, tell me what is the output, right? So what is the output that you get from the model that is stored in Y? Now I need to identify what is the error in that. So what I should do, whatever the ANN model is giving you, that's your Y. So what is small y is? Small y represents ANN output and Y2 represents ground truth. Okay, so when you compare your ground truth with your ANN output that is stored in error, find out the mean square error. So this is your testing error. So you can identify two in the problem. One is your training error also you can see, and how much testing error you are getting that also you can see. And this iteration, it's being continued for the 75 data set, and all the outputs if you want to display, you can use this command. So this is what a basic ANN model code for a classification problem. Okay, so this, if the participants need it, we can share it in your mail. So let us now run the file. Okay, you can see now what has been carried out. Now your model is being fetched using the code, and how many iterations, what is the time, what is the performance, what is the gradient you obtain, because I have used Levenberg Macadot algorithm, so it has a gradient function, and validation checking. So what type of architecture we have used, this is what the architecture. I have an input layer, I have hidden layers, I have output layers. This is what the weights and bias you adjusted. Right. So what does it tells you is I have 4 inputs. We had 4 inputs: sepal length, width, and then similarly petal length and petal width. And we had only 3 outputs. It can be 010 or 001. So that's what it tells you. So 3 outputs. And how many neurons in the hidden layer I have identified is 20. So that's we'll be writing in the code only. So it tells you my performance goal is met. So if you see the command window, you can see the outputs. So that's what it tells you, how your model is accurate. So if you have a real time application, your accuracy has to be more, so that this testing and training errors should be much reduced. So when this algorithm runs, you can see the plot. You can see the performance plot like this: training, testing, validating stages. You can see the error histogram at different data points. That is the difference between the targets and the outputs. That is the ground truth and the ANN output. So this is what the basic tool that you can implement in Matlab, and you can study about for your own applications. You should first identify the application where you get a data set, and then implement in this code, and you can study your ANN feed-forward neural network. So I'll stop sharing. Yes, thank you. So first of all, I thank all the participants being here for understanding, for your very keen observation in knowing about the machine learning, ocean survey, and sampling. So we also wish like you should use your the toolboxes or different platforms in which you can understand your data set and go with the machine learning algorithms for your own applications. So if you have any questions, I can answer.
Thank you, ma'am. It was very interesting topic to cover upon. And we have a couple of questions from students. First one from Roshan Singh is: machine learning can be used for detecting acoustic noise underwater? Brief explanation will help.
Yes, okay. So when you are using machine learning for detecting acoustic noise, yes, machine learning can be used for acoustic noise also. So when you want to identify the noise classification, or you want to detect some noises and all, so that is possible with the machine learning. So that's what I want to tell you. Any application, if you have a classification problem, or if you have a regression problem, what is classifying? I want to classify the noises in the acoustic signals. Yes, I can do with the machine learning algorithm. If you have a regression problem in which you want to tell a number, or you want to predict a value out of it, that also can be done with a machine learning tool. So it is possible.
Okay, ma'am. One more question from SRMENT. What is training set and test set in a machine learning model? How much data will you allocate for your training, validation, and test sets?
Okay, training set is what the data set that you use for the training your network, and testing data set is for validating your model. So when you use a training data set, your model will understand the data set using the training data. And when you want to test your model, whether it is correct or not, it is able to identify or not, you can give only the input of the test data set, and you can tell the ANN to give the output. So in that way, and how will you allocate means your training has to be more. Your training data set should be 75% in your complete data set, so that the machine tool understands it's much. If your training data set is very less, then the model cannot understand your data set.
Hello?
Yes.
Okay. Okay, ma'am, that's it.
So I think one more question is there. What is the specification? Okay.
They are asking the specification of your PC, ma'am, because the neural network and other kind of training runs very well. So that is the reason why they are asking this question.
No, it's not with the specification of the laptop. Whatever I have shown you today, it can run with any specification. This because this is a very basic model which I have told you today. When this GPU, RAM and all it's needed much is when suppose you're using a processor. Okay, so you want to dump your neural network in a processor. I'm using a Raspberry Pi or something like that, or if my data set is something the data set is it's in numbers, it's in integers. If suppose your data set are images, if your data sets are videos, then only your processor, you need to think about it. For the data set which is having numbers, if the data set values are very less, then any laptop can work with that. If suppose your data set itself is it's having a huge data set of it's having images or it's having video frames and all, then this processor cannot work. So automatically you can go with the high-end processors.
Okay, ma'am. Okay, ma'am.
Thank you, ma'am. Students, I have shared the Google form link for feedback link for your e-certificates. Kindly fill the e-certificates link to obtain your corresponding e-certificate. And if you have any queries, you can always post to mtsindiasection@gmail.com. Is Sivakumar sir available? Can you see Raghavendra?
Yeah, sir is available.
Oh.
Am I audible?
Yes, sir.
Yeah, you're audible, sir. Yes, sir.
He requests you to propose a vote of thanks, sir.
Good evening, everyone. It has been a very fascinating and very engaging webinar session. It's my privilege to propose the vote of thanks on behalf of the Marine Technology Society, India section. First and foremost, we want to express our gratitude to the President MTS, Dr. Zenka Willis, for her continuous motivation and support to the MTS India section. Our heartfelt thanks goes out to Dr. Venkatesan, Chair MTS India section, for his outstanding contributions towards the growth of MTS India section to great heights, and for being our backbone in our endeavor, constantly motivating and inspiring us throughout. Our sincere thanks to Mr. Nanda Kumar, Secretary MTS India section, who has been instrumental in the rapid growth of MTS India section across the country. His significant contributions has led to the expansion of MTS student section across the universities and colleges across the countries. Our special thanks to Mr. Rajaraman, Vice President Norinco Private Limited, for his informative speech on the topic Ocean Survey and Sampling, which has covered the detailed concepts of ocean survey and sampling techniques. Our special thanks to Dr. Preeta Rosalind, student coordinator, for conducting the practical session in machine learning. The session was very informative. We thank all the student participants, faculty members from various universities and colleges for your interest and valuable time for participating in the webinar. The participation in large numbers have made this webinar a huge success. Finally, we thank all the members of MTS Society. A special thanks to Ms. Hema for all her arrangements. And thank you all for participating in the webinar.
Thank you, sir. One more general reminder for the students. We have our SRM MTS FTech competition. The last date for submission is August 31st. And you will have all the news information regarding the competition in our website, also in our social media pages. You can register and win exciting prizes. I think we will wind up the session. Group photo. Raghavendra.
Yeah, first of all, I request the speakers as well as the committee members to come on the screen so that I can able to take a screenshot. Later on, we can able to have a participants, and we need a feedback from the participants also.
Any student willing to share the feedback orally? Turning on your mic.
Participants have the access to unmute themselves. They can able to unmute and they can able to say their name as well as the institution, and they can able to share their valuable feedbacks.
You can share your feedbacks. Next section will be based on your feedbacks. Anyone interested? Okay, that's fine. Shall we take the picture?
Yeah, I request participants also to come in video so that I can able to take the screenshot as a group photo.
Please turn on your video.
I repeat, participants, you can able to turn on your video so that I can able to take a group photo. Yeah, thank you. Thank you.
Thank you, one and all. Thank you so much.
Thank you all.
Thank you. Thank you very much.
Bye, sir.
Good luck. Stay safe.
Yes, sir. Thank you, Rajaraman, sir. Bye.
Thank you, sir.
Thank you.
Bye, Raja. See you. Bye. Bye, Raja.
Bye. Bye, Shiva. Thank you.
Bye. Bye.
See
Bye.
you.
Assalamualaikum.
Yeah, I'm closing the session. I'm closing the Zoom meeting. Okay.
Okay, okay, Raghavendran.
thank
Thank you
you.
so much. Thank you so much.
Yeah,
Okay.
thank you.